Swayam Prabha. Digital India. Educated India.
Hello, today in module 4 we are going to discuss a new topic, that is vacuum components. Components are very important in vacuum technology. They can be small flanges, valves, reducers, seals or manipulators. These are passive components which are there to couple various subsystems in a vacuum technology to make a broad vacuum system for a particular application. So, in this components lecture, you will be getting a coverage of introduction to vacuum components first, and different types of components we will be showing you, and little bit of discussion on flanges, couplings, seals will be done, and the controlling valves or shut off valves which are used in typical process industries we will be discussing. And towards the end, very sophisticated manipulators which are compatible to vacuum also we will be introducing, because these are very important in nuclear processes, semiconducting processes and even space technology, for example, metallurgy, where you cannot put your hand inside, but you need to manipulate, you have to do some translation, some rotation. So, all these things broadly come under components, vacuum components. Now, from the figure you can very easily find out how complicated a vacuum system looks like. It contains several pumps, several gauges, several windows, several chambers, several elbows, flexible bellows and interlocking chambers with gate valves and variety of electrical feed throughs and manipulators. So many varieties are there. Interconnecting pumping system, process chamber, control systems or many other subsystems which you may have to have in a process industry related to vacuum technology. If you can make some flexible small components with which you can connect all of them, you have an immediate advantage. Tomorrow you can remove those things and use the same components for some other system. That is the reason in vacuum technology, over a period they have standardized the type of components, geometry, shape, everything has been standardized, so that you can couple this and tomorrow you do not need it, you need a bigger one, that is also available on the shelf. You do not have to make it in separately that day in a workshop. So, these are all standardized couplings. They are very important in high tech industries, otherwise you will be spending a lot of time, particularly when you have a startup, you wanted to do some semiconducting startup. On one side you have to worry about materials, chambers, their surface finish, pumps purchase and intercouplings, conductance calculations, valves, manipulators. Where will you start? So, there are some standard things, you assemble them, collage them. That is how vacuum systems nowadays can be easily made if you have some knowledge and idea of what level of vacuum you are talking, which application you are talking, then necessary components you can purchase. Of course, chamber you have to make according to the process requirement, and pumps have to be designed. Design means their pumping capacities. You do not make a pump. The pumping capacities have to be finalized, and the precision with which you are measuring, then you will have to decide the gauges. And if you are interested in chemistry of the residual gas, you have to purchase residual gas analyzers and troubleshoot it in a comfortable manner, then you should also purchase leak detectors. So, like that several subsystems, and if you go to very small scale, they are called components. Last class we have seen materials. With those materials, chambers are made, pumps are made, components are also made. So, all the rules that we have laid down for materials are valid for components. Components also should have very high quality surface finish. They should also not degas, and they should be easy to couple and remove it, so that it will not contribute unnecessary contamination to the process. So, like that. There are standard specifications, ISO, KF, ISO standards are there. Some people call DN standard, nominal dia. Finally, any component has got a particular diameter through which the flow takes place, if whether it is a valve or a pipe or a flange or coupling. You can see those things here, several components with different shapes, different diameters, and they are coupled with various user friendly components, valves, L's, T's, chambers and gauges, manipulators. Here you will see so many small components. You have to make it with ultra high vacuum compatible, then only you will have high tech industries, particularly in IC chip manufacturing, semiconductor industries, or high tech metallurgy, or even space simulation, etc. In cryogenic technology used for nuclear fusion, you have to have such complicated shapes, but flexibility is there inside, otherwise it will take a lot of time to assemble the whole thing. Okay. So, this is how the components are playing very important role in making a vacuum system, and if they are standardized, we can reuse them anywhere, and if they are having good surface finish, they will not spoil the vacuum, they will only be useful in connecting or controlling the process. These are some of the standard components, small components I am showing, so that you get used to these words. In vacuum technology, these are the words you have to first get used to. There can be a small cross connection or an elbow, or elbow in this shape, a small coupling, clamping ring, small piece is like a pipe only with flanges attached, so that you can increase little bit of delta x length in an otherwise a long coupling. There is a piping, copper piping or stasis piping, whatever is there between chamber and the pump, but these are additional components you have to introduce for isolation, control or additional length. All these things are small components, on the spot you have to do it. You cannot suddenly realize a vacuum system just from chambers and pumps or pipes or any plumbing work. It is not like a household plumbing work. You have to have maximum conductance, so that minimum pump down time will be there. So, you have to use those components, and some components are ultra high vacuum compatible, some components are high vacuum compatible. So, when you are dealing with normal vacuum, you should not unnecessarily purchase very costly components. So, you should also decide your budget, and when you want to have a very high conductance between the silicon preparation chamber, wafer preparation chamber and main growth chamber, they are separated by a gate wall. Why? Because it is very comfortable to open the gate and transport the silicon wafer for the next stage processing. At the same time, conductances are quite high and convenience is also quite high. And while doing that, there will be a magnetically coupled magic arms will be there for doing all this robotic motion inside, whether it is x, y, z or tilt or rotation. All these things come under a broad category of components. Well, because of limited time, I am trying to put more words into your mind, but slowly you watch these pieces, and towards the end of the lecture, I will also show some of the things which we have in the lab, different TE cells, etc. For high vacuum, you have to use metal gaskets. For normal vacuum, you can use a neoprene or Viton gasket centered with a small aluminum ring, and how to couple that in a KF coupling, all that we will see, how to clamp it. And if you want some flexibility, you can use bellows, because when you are plumbing a chamber, pump, etc., it cannot be exactly matching while you are finally connecting it. There may be little flexibility requirement. At that time, the small bellow will take care of that. Initial days of vacuum technology, these were not there. They were having a lot of tough time. And if you cannot introduce rubber pipes, because they will degas, and a very high quality brazing here, otherwise they will leak. You cannot have a flexible thing which is leaky. And this is the gate wall, for example. Control valves are there, like bellow valves. The bellow will isolate vacuum from the atmosphere. So, all these things over a period of time they have developed, and today they are standardized. There are many companies who are manufacturing these couplings. For example, in UHV flange is a very shiny piece with conflat here. We will discuss these things little later. You will find ultra high vacuum flanges couplings are very shiny, because they are polished to such a level that degassing effects are minimum. For 1 tar, 10 tar, you do not have to do it, because it is very costly. If you have to make a ultra high vacuum compatible flange or normal flange, there can be a cost difference sometimes 10 times, though it looks diameter, thickness, material same, but the finishing is different at component level. So, these are various standard components we normally come across in the lab. Friends, after discussing components, I thought of showing some components that we have in our laboratory at IIT Kharagpur. For example, I told you a cross. These are having 4 flanges. So, you can make different connections at various points. Then you have a T connection. Similarly, you have L connection. And how do you choose? L means wherever you require L type of connection, but the dimension has to be DN 42, DN 25, that means 25 millimeter or 42 millimeter, you have to specify. And when you are not using this, you should close it with a plastic cup. Otherwise, if there is a small ant or something has gone, and if it is dead inside and something fluids come out, at 10 power minus 5 tar minus 6 tar, it will produce enormous amount of gas and you will never get vacuum. So, you must be very careful, and you should not sweat, and if you try with this sweat here, it will form a monolayer at 10 power minus 9 tar, it will take 10 days to get 10 power minus 10 tar, and if you are not doing, if you are doing with the gloves, it will come in 10 power minus 10 tar maybe in 1 day. So, you have to be very careful, and at times larger diameter to smaller diameter, a reducer is required. And if you want to have flexibility in a long piping network, because it is not matching, then you require a flexible bellow. This is a flexible bellow. And valves are there. For gas inlets, there is a calibrated flow rate needle valve, through which one side is atmosphere, the other side is connected to high vacuum. And these are right angle valves with bellow inside. When I try to do this in a manual operation, it opens up the bottom seal and it gets engaged. It is a beautiful way of isolating 2 chambers at minus 5 tar type of things. But at minus 7, minus 8 when you go, you have to use all metal valves. And typical couplings that we see in day to day life for connecting pipes. The actual plumbing work gets soldered to this. This is my flange coupling type thing, KF coupling. This is a routine -5 to -6 star, and this is my center ring and O-ring. The center one is, the center ring is aluminum, and this is my O-ring. So, you can center it. Why I call it center is, when I put it here, it gets centered, so that it will not fall, because this extra protrusion will go into the slot and the O-ring portion touches this, and next section the other mating flange will come here. Then you put a coupling, and these are 15 degrees, so that when you apply force here, a part of the component goes here with a smooth pressurizing like this, so that the small roughness that may be there in micron level gets compensated by this O-ring. These are called O-rings because it looks like a O, and these are neoprene in normal vacuum, Viton for high vacuum. But none of these things are good for ultra high vacuum. In ultra high vacuum, you require a flange like this, conflat flange, wherein I will put a copper gasket and another conflat flange like this. You see how shining it is, because these are all ultra high vacuum, and you have to put that, within that a copper gasket is there. So, this cone will apply huge pressure on that copper gasket, so that yield stress will cross and it will form a seal. There is no polymer here. So, you try to tighten it with a good torque, so that it forms a all metal seal for ultra high vacuum. And nowadays in process control, you can control it electropneumatically. So, same wall you can connect it to an electrical power supply. Whenever you want, then indicator will come out, so that it is open, and there is a pneumatic connection is given here. So, that will be able to lift it, that elbow, the whatever bellow that is there, instead of manually doing like this, you will be doing the automatic things. Similarly, gate valves, varieties of automation are coming nowadays. So, different flanges, different couplings, different valves, different blind flanges, for example, high vacuum or normal vacuum, you have to select properly and decide your components. So, that degassing is minimum, convenience is maximum, and your comfort is very good, and it will not be leaky. It should not produce leaks. Okay. Now, little bit zooming into that, let us see standard couplings that we have to employ in connecting the piping network, so that entire system can be realized with your ideas. For example, when you are making a thin film deposition, you require substrates, you require substrate manipulation, you require shutters, you require source materials, you require electrical feed throughs, you require a bell jar, you require optical window, you require a backing line, a roughing line, you require backing walls, roughing walls, air admittance walls, interconnecting flexible bellows, walls, seals, so gauges. You have to be careful in choosing all of them. Okay. Now, let us see a typical couplings. The top one is KF coupling. KF is Klein flange in German. Klein means small flange couplings, and they are quick couplings. You can connect it, and again you can change this clamp. You can just loosen the clamp, immediately all the things will come out, and these two bushes are soldered to the piping. So, these are available commercially. So, you purchase pipe from somewhere, you attach these things and add some flexibility by bellows and connect it in the way you want, the pumps and chambers, etc. While doing so, be careful that you have to use the gasket material compatible to the level of vacuum. If it is a ultra high vacuum, you cannot use such a neoprene or polymer or Viton. You have to use gaskets like copper gasket, OFSC copper gasket. You cannot use this type of simple flanges, you have to have conflat flanges. We will discuss little later what is conflat flange later. So, coming back to KF coupling, these two mating tubes are tapered to 15 degrees and inside which there are some countersunk slots are there, and into that this center ring, which is an aluminum ring which is supporting the O-ring, it will slip, and between these two flange areas the O-ring portion touches, and on top of that if you put this clamp and tighten it, then you will get a coupling. When you do that, the gasket will get squeezed between these two flanges and form a seal from the atmosphere. This is good enough for 10 power minus 6 torr minus 7 torr. But if you go to 10 power minus 7 torr minus 8 torr minus 9 torr, 10 power minus 10 torr, you cannot use these things, and you need to bake the systems. If you bake, this will melt. These are all neoprene and rubber, this type of products, they will melt and they will degas, they will absorb lot of moisture. These problems we will see in the high vacuum system design, next section, how all these aspects are rediscussed again with respect to system design. Okay. When you go to ultra high vacuum, the flanges will be looking like this. This flange will not look like this, because this is not a quick coupling. There are holes through which you introduce nut and bolt and tighten it to such a torque, the stress that is there on the metal gasket will approach yield stress. So, that this is a connected version here, the same thing I am showing it here. So, when you tighten these bolts, it gets almost squeezed type thing, and it will form a room temperature brazing type of seal between these two mating flanges. So, that cross leak from the atmosphere will not be there, and since all are metals here, it is an all metal seal, there will not be degassing problem, and you can bake such systems, and same thing is shown in a zoomed way here. Okay. These are called conflat flanges, because if you carefully observe this portion here, it is like a cone type thing here and flat here. So, when you are applying force using nut and bolt, this sharp edge will touch here with lot of stress, because area is less. For a same force, if area is less, stress will be more, and that stress, if it crosses yield stress, you will start getting sealing effect. It is as simple as that, and these are explained very well in Wikipedia. So, for lack of time, it will not be possible for me to go into the details, because it is a big field by itself, which is an essential field to make ultra high vacuum systems for high tech systems, for high tech applications. Similarly, you have control valves. They can be called control valves, they can be called isolation valves. For example, diffusion pump, there is a backing line, there is a roughing line, there is a main isolation valve. Why? Because first we need to evacuate using a rotary pump from atmosphere to minus 2 torr, then close that valve. Then the same rotary pump is connected in the backing line through another valve, which was originally closed during the roughing stage. That will be supplying the enough backing action to the diffusion pump. When diffusion pump and rotary pump together have created good vacuum, then you open the main isolation valve, assuming by that time the top vacuum system is not leaky. So, whatever vacuum that has been created at 10 power minus 2 torr by the roughing line is retained. Now, when you open it, 10 power minus 6 torr is instantly connected, and to make a good conductance you make a gate valve there or cold trap, all these things we have seen, these are all components. When you do that intelligently, you can get fast pump down. If you make a mistake, it can be a leaky system, you can introduce leaks, that is one mistake, or you introduce a very poor conductance, you will not get vacuum. So, components should be chosen like that, but valves are required to isolate at various timings. So, valves are very important components in high vacuum technology. There can be bellow sealed valves with 90 degree type of thing or same direction opening. varieties of valves are there. Later I will show you actual valves that we have in the lab. This is a gate valve, it is like a gate opening. So, you just open it and pull all the gate entirely into another chamber, so that the coupling will give you beautiful conductance. So that this chamber this side is connected to this side chamber, both are vacuum, without much of any material coming in between, because in molecular flow if any material comes, it will obstruct and flow will be coming down. So, the gate valves give very high conductance. Similarly, needle valves are required in semiconducting growth process or various other chemical CVD processes, etc., where you will be letting in some gases for plasma processing, etc. So, they should be controlled. On one side high vacuum, other side atmospheric pressure almost, but very pure gases. Later in vacuum metallurgical furnace design, we will see what do we mean by pure. 99.999% purity is equivalent to 10 power minus 4 torr purity. That we will see when you take up a case study of metallurgical furnaces with all this knowledge of chambers, components, conductances, whatever we have discussed. With this knowledge, we will design one particular case study, that is metallurgical furnaces, where we will again show these components there. This is a diaphragm valve, good old valve, since long people are using, nowadays they are not using. Ball valves are there, which are also very good throughput. So, these are all routine things which we have seen in high pressure piping also. Here the seals and coupling should be compatible, there should not be leak from the atmosphere to the inside. If you can take care of that, a mechanical engineer will be able to easily design these valves with good conductance and with good controllability. Once time it works, second time it gets stuck, then you are in trouble, particularly gate valves. Sometimes it gets stuck and everything is going on, and semiconducting wafer has to be transferred, that suddenly gate valve gets stuck. Nowadays all these valves are engaged with electropneumatic, so that from a remote place you can control and open, close, etc. Very soon artificial intelligence, IoT controllers, fuzzy logics will come. So, varieties of things are now coming, electrical, electronics and programming and mechanical and instrumentation, all the fields are joining along with metallurgy, along with chemistry, physics. Then only you can make beautiful devices for nuclear fusion and semiconducting devices, high speed memory elements and high speed integrated circuits, and very high quality metallurgical alloys for very specialized purposes like artificial limbs, etc. The purities are very important. You cannot do anything in atmospheric pressure. So, unless you have a high quality components, you cannot obviously realize these processes. So, while I am discussing components, I want all the students to understand that our main aim is to get perfect vacuum, fast vacuum, clean vacuum, and you can manipulate many things inside and do the process and get the device out. Now, at the end, in a vacuum system, we need to do something inside, but the action is outside, the reaction is inside. Such situations will come, particularly nuclear process, etc. You cannot approach the place where actual processes are going on, even the thin film growth or many other plasma processes, you cannot go inside. Even the manipulators have to be designed in such a way that very precisely it will open shutter, in such a way flux is controlled, or it will electromagnetically we are controlling something. So, some other motion is going on inside, whether it is a translation or rotary motion. So, that process is controlled properly. You will get what the type of thin film that you want, with this many moles of gas, another moles of another component, multi-layer depositions. When you want to do such complicated processes for making sensors or for making chips, IC chips, or for making various circuits or mirror coatings or engineering coatings, you have to be extremely careful. So, a lot of manipulation is required. Sometimes it can be automated manipulation. So, these are some of the standard manipulators people are using, like
These are all vacuum manipulators, and these are available commercially now and very high quality. Of course, cost will be little high, but if you do not require that much sophistication, you can make your own manipulators. For example, this is a simple manipulator, you can make it in your laboratory, just lip seal type of thing, some people call it Wilson seals, and just apply pressure, it will hold the shaft. Then even if you rotate this shaft, air will not leak in. These concepts are known long back, but today we have very specialized shaft seals like ferrofluidic seals. There is a ferrofluid, a fluid with suspended particles, magnetic particles, they will form a magnetic circuit, and in the process, by making certain elements magnetic, and while it is rotating, the fluid property is used to stick to the shaft tightly like a seal, like a shaft seal. The liquid is pressing radially. These are called ferrofluid seals. This side you have very high vacuum, this side is atmosphere. Well, for lack of time, it will be difficult for me to explain, but it is a beautiful piece of equipment. You can just see in the Wikipedia ferrofluid vacuum seals for a UHV. These are 5 axis vacuum manipulators, X, Y, Z, tilt and rotation. In any space, if you have these 5 degrees of freedom, X, Y, Z and tilt and rotation, you can approach any point. Multi-layer depositions or fixing the substrate to different layers at different sources of gases at different timings, etc., you require such manipulation. Sometimes wobbling motion, tilting motion, all these things, some orbiting motions, linear feed throughs for example, they are commercially available with the KF flanges. This 16 is the nominal dia, 16 mm. So, this type of things, they are made with all the necessary controls and instrumentation. At the end there is a flange coupling. So, you can just introduce it to your body of the chamber, that is all, then you can use it as a manipulator. Similarly, these bellows give flexibility, so that whatever manual you are doing X, Y, Z, inside that stem will take it the reaction, so that you can shift any material from one place to the other, or you can move something inside from control from outside. These are all very essential requirements in high tech industry, and if you are not doing, you will be very slow. Each component will take 10 days. Now, VLSI circuits and nuclear processes, space manipulators, space simulators, timing also matters. Process industries, even in pharmaceutical industries, any food processing industry, time, automation, these are all coming up in a big way. So, vacuum technology also has adjusted itself with very high tech manipulators, high tech valves, high tech flanges, high tech seals, high tech couplings, depending on the vacuum level. If it is ultra high vacuum, all metal. If it is normal vacuum, seal portion can be neoprene or some other Viton gaskets, like that. So, you must have a good knowledge of materials, which we have already covered in the last class. If necessary, you again go to that class, and these components. Then with these things, we will go into the next class, where we will be discussing chamber design, thickness calculations. Otherwise, you will end up in purchasing unnecessarily lot of material. Here also, you have to finalize the materials. You cannot use any material you want. These are not only mechanical devices, they are mechanical devices suitable for vacuum technology. So, surface finish is very important in those portions. For example, vacuum side, this side surface finish is not required, here it is required. So, it is a highly sophisticated material, that is the reason they are costly. But I would suggest some startups to come up, you can easily make these things. You are not making any high quality chambers or high quality pumps, etc., but you can make your own inexpensive, innovative such manipulators, then you will have a very good market for it. In fact, I want new youngsters to come up with more and more ideas, because today lots of controllers are available, electromagnetic controllers are available, SCADA controllers, and remote IoT is available. So, things are changing, you can add any dimension to anything in vacuum technology, and vacuum is after all a clean process. So, this component level research is very important. You may be thinking, instead of concentrating on components I am giving you, because these components you will get in every manual of so many companies. But I am only trying to highlight the importance of components while interconnecting subsystems to make a overall system to satisfy your main aim of getting fast vacuum and clean vacuum and controllable process. So, to conclude this section of vacuum components, standardized vacuum components are now being made all over the world and with very good surface finish, so that they are vacuum compatible. What are these components? They can be valves or flanges or seals or interconnecting piping or any small things which are required within the vacuum system, which is an independent item. It cannot be welded to the main chamber. These are called vacuum components. These are coming up in a big way, and this is the area where lot of startups can come. Then they can be repeatedly used. You can take out, tomorrow I can use, and they can be exchanged with somebody else. You can give it to your neighbor to in his industry when you are not using it much. Okay. And they should be compatible to the level of vacuum. With low degassing is very important for ultra high vacuum. Gate valves are very expensive, you have to use when high conductance is required. Needle valves with high precision and repeatability should be there. Backlash should not be there for perfect mass flow controllers of gases to realize plasma processes. And precision manipulators XYZ and tilting and rotation are required, like molecular beam epitaxy or various other engineering coating industries or space simulation chambers or nuclear processes, etc., or semiconducting manufacturing. You require a lot of manipulations. With their good knowledge of all these things available in manuals and internet, I am sure you will be able to choose the components with minimum contamination. And when you are not using these components, you must put them or store them in good containers, pack them properly, keep it in airtight things. This is equally important. That is the reason last conclusion is the person concerned should maintain these components. If you do that, you will get very good quality service of the overall system for different applications. Thank you.